In the previous video, we introduced the concept of derivative. We said that if I have a function which I call x in the previous video, and this function is a function of argument t, in this case, if I want to know what derivative of x with respect to t is at when t equals to point t1, that simply we take x at some other point t2, we subtract x at the point of t1, where we're interested in derivative, and divide by the difference between t2 and t1. The next thing we need to do, we need to start bringing t2 as closer and closer and closer to t1. And when we write it, we say limit of t2 going to t1. And that's how the derivative is defined. Now what we're going to do, we're going to rewrite this a little bit in a more convenient form for us. Now let's, instead of writing t1, we're going to just write t. So t1 becomes t in new notation. Another thing, we're going to use a notation delta t to indicate the difference between t2 and t1. And if we do this, t2 could be rewritten as t plus delta t. And our formula becomes so df dx dt, in this case at the point t, will be limit of what? X of t plus delta t minus x of t divided by delta t. And now what we need to do, we need to, since we were saying that the second moment t plus t2 has to get closer and closer and closer to t1, equivalent of this will be making delta t closer and closer and closer to 0. So really what I wrote before and what I wrote now is pretty much equivalent, but this is a formulation that is more convenient for us for what we're going to do next. And let's use this definition to look at simple functions and calculate derivatives of very simple functions. And first simple function we want to talk about is a constant. So let's assume that x of t is a constant. Doesn't matter what this constant is, we're just going to call it constant c. Well, since x doesn't change with t, x of t plus delta t also going to be c. The next thing you want to do, you want to calculate the difference of x t plus delta t minus x of t divided by delta t. Well, it's a c minus c divided by delta t, which is 0 divided by delta t, which is 0. All right. And the next thing we need to do, if you look back, is look where this ratio is going to go when delta t goes to 0. Well, where's this thing going to go? It is 0 at any delta t. So regardless of what delta t we takes, big or small, well, as long as it's not 0, 0 will stay 0, which means the derivative of the function of a constant is 0. Let's write it down like d dt of a constant is 0. And that's what we actually were talking about before. If we look at t versus x, this is our c, this is our function. It's a straight line with a slope of 0, and we discussed that before. We said that derivative is actually the slope of this line. Well, the slope has to be 0. The other way to look at this is say, well, a derivative is a rate of change of this function. Well, the function does not change. What is the rate of change? It's big fat 0. So those kind of ways to look at this fact, they all give us the same answer. Well, in fact, if they didn't, we would be in trouble. So let's look at the next function. Next function is just x of t equals t. What does it mean? It means that, well, the next thing we need to do is to calculate x of t plus delta t. Well, if x of t is t, x of t plus delta t, we simply need to plug t plus delta t instead of t in our formula. Get t plus delta t. Next thing we're gonna do, we're gonna calculate this ratio, and it's gonna be t plus delta t minus t divided by delta t. Guess what happens? Here's t here, here's minus t here, they cancel out. And what we have left is delta t divided by delta t. Which is 1. So once we calculate this ratio, the next thing we want to do, we want to see where this ratio is going to go when delta t starts going to 0. Well, this ratio is 1, regardless of delta t. So if delta t starts going to 0, well, it's still going to be 1. So we can write down the following thing. We're going to say that derivative of t is 1. And that's again makes sense, because what is x equals to t? X equals to t is a straight line that goes from the origin of coordinate system. So x equals to t. And that's the line that goes at 45 degrees. We talk about the slope of this line. The slope is the coefficient in front of t, and the coefficient sitting here is 1. So again, that makes sense. The other way to look at it is, again, if you remember some trigonometry, you know that the tangent of this angle is our slope. But this angle is 45 degrees, and tangent of 45 degrees is 1. Again, everything works out the way we want it. And let's look for now another example. A little bit more complicated. And that's x of t equals t squared. Well, what we'll do, we obviously need to calculate the value of x of t plus delta t, which is simply t plus delta t squared. And to go further, we need to remember one formula. And the formula says the following, that if you have arbitrary a and b, and you square it, it's equal a squared plus 2ab plus b squared. If you don't know this formula, I suggest you learn it. And even better if you know how to derive it. So, but here we're just going to apply this formula. Obviously, in our case, a is really going to be t, b is going to be delta t, So when we take t plus delta t squared, we're going to get t squared plus 2t delta t plus delta t squared. So what do we do next? As before, we calculate that ratio of x of t plus delta t minus x of t divided by delta t, which is going to be t squared plus 2t delta t plus delta t squared minus t squared divided by delta t. All right. Well, we see that t squared and minus t squared, they go away. What's left is 2t delta t plus delta t squared divided by delta t. So to calculate that, we're going to divide by delta t both of those terms in the numerator, and we get 2t plus delta t. So the next thing we need to do, we need to see where the thing is going to go when delta t start going to 0. Well, let's look at each term. Well, the first term, well, doesn't depend on delta t. So no matter what delta t is, it's still going to be 2t. Remember, t is a fixed point. So this is going to be delta t when delta t goes to 0. But obviously delta t is going to go to 0 when delta t, well, let me say delta t should go to 0. And as a result, this thing is going to go to 2t. So what we can say now is d t squared dt is equals to 2t. Now, I want to look at the graph as before. Let's look at x equals t squared. That is a parabola. That is 0 at the origin, and then it goes up. So if you remember what we talk about when we talk about the derivative in the previous video, we said derivative is a slope of kind of a line, what's called tangential line, and that line is kind of the line that touches this curve, okay? It doesn't cross it really, but touches at one point. So, and what we find that, if you look, the line that touches the parabola when t equals to 0 is horizontal axis, right? And that's a straight line that goes horizontally, which has the slope of 0. So we predict that derivative at t equals to 0 should be 0. And again, if you check the formula, which equals, that tells you the derivative is 2t, or t0 is 0. Now let's look at t greater than 0. The derivative of t squared is 2t, so t is greater than 0, 2t is greater than 0. Derivative is positive, which means that derivative, it means that the slope of the tangential curve, tangent curve, is positive. And if you pick up any point for t greater than 0, there's a line that goes up, okay, which fits that description. On the other hand, if you look at t less than 0, the formula tells us that derivative should be 0. Well, if we pick up a slope here of the line that kind of touches our parabola, that line is going down. So the slope of this line is going to be negative. So again, it fits the formula. So again, it couldn't be any other way, otherwise it wouldn't be math. You have different ways to look. When you'll start looking at the functions for things different ways, you're gonna get different answers. That would not be good. But so far, so good. Everything matches. So we're gonna continue into the next video where we're gonna look at derivative of more complicated functions. See you then.